Hi, welcome to this SimplyMaya tutorial on Maya fluid dynamics. In this series we're going to take a look at all the different aspects of Maya fluids. We're going to cover the basics and hopefully give you an understanding of how the fluid system in Maya works so you can start to create your own effect. We'll also be taking a look at the difference between 2D and 3D fluid containers. We'll be seeing how we can use nparticles to interact with our fluids, and we'll also be creating a few effects that everybody should know how to do. Some smoke and fire, some fire on its own, some smoke on its own. We'll also be doing a few special effects going towards the more weird and wonderful to give you some examples that it's not just smoke and fire you can use Maya's fluid effects for. You can also do some great off-the-wall wacky special effects with it as well. So we'll be taking a look at all that throughout the series. In this first part, I'd like to concentrate on the basics of what a fluid container is, what it does and why it does it. So to that end, I've decided to use a 2D fluid container. Now, it might sound a bit strange to use a 2D fluid container within a 3D environment, but if you think about it, if your fluid is not interacting with any other 3D object in the scene, and you're not going to pan your camera about, i.e. your camera is going to be static, and you're not going to create a column of smoke that interacts with other objects in your scene, or a column of fire, or whatever effect you're going for, if it doesn't interact with any other object within the scene, and you're not moving your camera, then generally it will be a lot faster to get the same effect with a 2D container. 2D containers are also a great way of creating an image sequence to later use as a texture map for other objects that you might want to put effects on. We'll delve into that in greater detail in the coming lessons, but right now I'm just going to select the dynamics menu from up here. I am going to the fluid effects. I'm going to create 2D container. Options, I'll just make sure it's reset, and I'll hit apply and close. You'll see X and Y here have a size of 10, and you'll see Z has a size of 0.250. Basically Z doesn't exist in this equation as it's a 2D container. This is more for our reference more than anything else. We can only actually add resolution to the container in X and Y. So I'll just hit apply and close with the standard settings. I'll just get rid of the grid. And the first thing you'll see is we've had this square box created that's 10 by 10 standard Maya units. Now, one of the reasons I've chosen to use a 2D fluid container, as I say, is it's simpler to demonstrate some of the principles in. It's also faster for us to use. Now you'll see here the first thing that pops up is the container properties. If you're watching this in Maya 2010, you will not have this keep voxel square checkbox. So I'm going to tell you a way around this in a second, but basically you'll see here that our base resolution is 40, so the resolution of this is 40 and this is 40. If I change this to 20, you'll see the resolution of this is now 40, but this is 20. So the voxels within the grid are actually still square. Uneven voxels can lead to a stretching of fluid, a look that's a little bit nasty. So bear in mind that in Maya 2010 you won't have this, you won't have the base resolution, you'll have to do this by hand, so you'll need to calculate the resolution for each particular size. Maya 2011 and 12 quite nicely just have this keep voxel square button. Now I can show you what a voxel is. What it does is it helps Maya calculate its fluids. So Maya will calculate what's happening in one voxel and it will spread that to the nearest voxels around it. The more voxels you have, the more complicated and more precise your fluid is going to be. Unfortunately, the longer it's going to take to calculate. So if we go down to the display tab and hit full under boundary draw, you can see here we now have 40 by 20 voxels, keeping them square. So each time the fluid passes through one of these, it's going to look at the surrounding ones to calculate what's going to happen next. And this way, as I say, the more of these you have, the more accurate your simulation is going to be. For instance, if we turn this to a base resolution of 100, you can see here that we have many more of these grids, voxel grids, to pass through, so we'll get probably a better fluid simulation. But increasing the base resolution to 100, you can see, has given us a lot more area to calculate. a lot more for Maya to do. So for this particular instance, I'm going to put this down to 40. I'm going to go back to the display and just turn it back to outline because I don't need to see this. I'm also going to just continue with the 10 by 10 square and a base resolution of 40. So again, we've gone 40, 40, and just to show you again, if I had to flip this onto full, it will still be square. So back to outline. What you will notice though is if I just hit R now and resize this in one dimension, you can see here that my voxels are not square any longer. Now they're decidedly unsquare. So when my fluid passes through these, it will have a tendency to stretch out along the axis here and be squashed in the axis here. This is why you shouldn't grab a fluid container and just start randomly resizing it about. A better option is to always go up here and set it to whatever it is you'd like it at. So if we just put this back to 40 and 40, and this back to 10 and 10. There we go. I've actually changed the size of my fluid container now. So I'll have to put my scale back here to 1, 1 and 1. And we go back to a perfectly square container with perfectly square voxels. This is not something that you should really spend too much time worrying about unless you're going to dive into more advanced fluid simulations. But just keep in mind that you generally want to keep your voxel square, and the less you have, the faster your simulation is going to be, but also the less accurate. So if you're looking for really high accuracy, or you need to do a shot at really high resolution, please bear in mind that once your base resolution gets above, say, 200, 250, you're going to be looking at 1 in 8 gigs of RAM, 16 gigs of RAM, you know, more if you can lay your hands on it. The 16 gigs of RAM should actually be perfectly fine, but you're going to need a fairly decent piece of hardware to go above 200 in base resolution and still be able to render and simulate any sort of reasonable speed. So please keep in mind that sometimes it's better to play with the textures, the colors, the incandescence, RAM, but and there's 100 other tricks we'll go through in this series, other than just to keep upping the base resolution, because you will run into problems with memory, processing power, and things of this nature if all you do is just keep cranking this base resolution up. Right, so just put this back to outline. So this is basically what this does. I'm going to leave the boundary X and Y for now, and I just want to let you show you the contents method. This is what is allowed to be emitted into this fluid container. So at the moment we have density set to dynamic grid. Now if we turn density off, you can think of density as sort of smoke for the purposes of this particular lesson. If you have density turned off, then you will get no density emitted into the scene. If it's on static grid, then it won't move, it will just stay static, and if it's on dynamic grid, it will calculate. I think the best way to demonstrate this is for me to put an emitter into our fluid container, so we can take a look at what these do when we turn them on and off. Okay, so I'm going to go up to fluids, I'm going to go to add edit contents, and I'm actually going to emit from an object. So what I'd like to do is just put a plane in here, and I'm just going to go into the channel box and I'm going to rotate that 90 degrees. Now I'm going to open my outliner, and you'll see here that we have our fluid container and we have our plane. So what we need to do is attach this plane to this fluid container and tell Maya that this is going to be used as a surface emitter to emit whatever we would like within this container. Now the way that we do that is we select the plane and then we shift select the container. You can also do it here in the outliner, which I prefer to do because when you've got a lot going on it's sometimes more accurate. So after I've done this, I go up to fluid effects and then add contents, emit from object. I'll select the object, the option box. Now after I've got that up, I'm just going to reset its settings. So if you do this, we should both have the same settings. Now the emitter type at the moment is surface, which is exactly what we want. We want it to emit from the surface of this plane here. Density, heat and fuel. Now you can think of the density as kind of smoke, the heat you can think of as heat, basically, fire. Fuel is kind of like an open gas main. It can be any sort of fuel. If you add heat to a container and then throw in a lot of voxels per second of fuel, it can be kind of like throwing a can of gasoline onto a fire, which we'll do later because it's educational and it's a lot of fun. Virtually in Maya, that is. We're not actually going out and throwing gasoline cans on fires. So what we've got here is we're going to do this one at a time. So I'm going to put, I don't want any heat released and I don't want any fuel released, and the fluid drop off is how fast the fluid is going to drop off from the edges of the container. I pretty much always go with 0.25 unless I'm looking for something in particular, and we will get into the particulars more as we go along. And if I just hit apply and close now, there we go, just took a little bit of time, and we give ourselves some frames to work with, and we hit play. You'll see here that it looks like particles. This is because I do not have shaded view on, so I'll push 6 on the keyboard. And you should see now what kind of looks a little bit like smoke emitted from the surface emitter. As you can see, with a resolution of 40, we're getting some pixelation here. I'll just render that. It's not very impressive. It's still not going to be very impressive, but you'll be able to see it a little more. So we've kind of got a sort of smoky feel to it. One of the problems is we can see the emitter, and the other problem is it actually looks nothing like smoke. So we're going to do quick two-dimensional smoke. First we'll go and select our fluid container, and we have density set to dynamic grid. If I turn it off, you'll see nothing will happen, because the only thing that this emitter is actually emitting is density, and the container itself won't accept density as one of its content methods, so nothing happens. It's as simple as that, really. If we put that back to dynamic grid, as you can see, we have the density that would have been emitted. Now, one other thing to note is you will have to rewind and resimulate, because although this is pretty speedy, it's a 2D container. You can't just jump around. You'll get some, as you can see, some very bizarre effects if you just try and jump around the timeline. Maya actually needs to simulate from the beginning of the scene, unless you were to say stop here and tell it that this was the initial state of the fluid, but we'll get into that more at a later time. So there it goes, our density. So as you can see, it just looks a little bit like really bad smoke being emitted into the container. Now we have velocity, temperature and fuel. I can turn all of these off at the moment, and you will see that now, because we have no velocity, we have nothing happening. You can still see there is some density being emitted, but it has nowhere to go. It has no movement, no external velocity force, so it just sits there. So if we turn this back on, you'll see now that we get our smoke, our pseudo smoke, rise up from this surface emitter. So just to make this a bit more interesting, I just want to scroll down here and I'll make sure that my shaded display is as render, because you can, one of the nice things about Maya's fluid system is you can isolate certain things. So if you have temperature, fuel, density in your scene, you can actually get it just to display. If I was to set just display temperature now, of course nothing would happen because we have no temperature in our scene, whereas if I go to just display density, we should get exactly what we had before, because there is just density in our scene. So for now I'm going to stick this on as render. Now I want to make this look a little bit more like smoke. There is a simple way of doing this straight away. If we go down to contents details, this is where we control our density, our velocity, our turbulence, temperature, fuel and color. So straight away you see I have a density scale of 0.5. Now, there's two ways to get more smoke in the scene. Well, actually, there's more than two ways, but for the purpose of this particular lesson, we're going to look at these two ways. If I increase the density scale to 1, I will get more smoke. In fact, you'll see there that it's a lot less grey and a lot more white. If I just put that at 10, will give us a better idea. Okay, so now we have more smoke. I will put this back where it was. We can also use the emitter itself. So if we go to the outliner here under fluid emitter, you'll see at the moment we're adding 1 density per second. So if we upcrack to 10, and there you go, we have a lot more smoke. I'll just give a more extreme example by upping it to 100, and there you go, lots more smoke. So I'm going to put that back down to 1 because it's all we need right now. Okay, and you'll also see here under the emitter attributes, because we're under the emitter now, not the fluid container, that we have heat set to add heat and add fuel. But as it's adding no heat, no fuel, they have no effect. So if you like, you can just go and flick those down to no emission. Doesn't make much of a difference. In fact, doesn't make any difference, but I like to put them on no emission. So when I'm flicking backwards and forwards, I can tell at a glance that I've purposefully turned off heat and fuel, and I haven't just left it set to 0 because I've, had a senior moment. Okay, now we should have our density back to where it was. We do indeed. So I'll go back to our fluid container and we'll get this to look a little bit more like smoke. So we'll go into what all of this does over the coming lessons, but right now I just want to go into the velocity and I want to go into the swirl, and I'm going to give this a swirl of 5. And now you see it doesn't look quite so arrow-like. So what I'm going to do is take that to 10, and now it doesn't look arrow-like at all. It's still not perfect smoke, but it's certainly a lot better if I just do 200 frames of this. And all I'm going to do now is turn on high details. So I'm just going to go here, and under dynamic simulation I am going to put high detail solve to all grids. This will give us a better view. You should be careful when using this, however. It can be quite a hog on resources, and also you should definitely be careful when using high swirl values and high detail solve together. This should be fine for our purposes, so I'll just rewind and play. You can see it actually plays a little bit slower, but it does give you a better idea of what's going on. And normally, like I've said, if you have a base resolution over 200, you're going to need quite a beast of a machine to get any decent speed out of it. But as we have a 2D fluid container, so Maya is doing much less work than it would be with a 3D fluid container, I'm just going to take a quick play blast of this for you guys, and I'll be back in a sec. Okay, my play blast finished. I think it took less than 10 seconds. I could have actually not paused, but there we go. Sometimes it takes longer than others. And if I play this back for you now, you will see what we actually made. So you can see, although I wouldn't call this great smoke by any stretch of the imagination, just adding a little velocity swirl, a little bit of density. We've done nothing else to this. We've just put one simple emitter in. We've used a simple emitter here, a polygon plane, surface emitter, and we have, achieved a much better smoke look than we had when we started out. Now, when we come back in the next lesson, we're going to continue to use 2D containers. We're going to delve into shading. We're going to go more into creating something that looks a little nicer than this. This was just basically to give you an idea of just the container properties and contents method. We also took a quick look at the dynamic simulation box, which is where we turned on the high detail solve. This is also where you get your gravity, your friction, your damp, your viscosity. You also took a look at the density scale, buoyancy and dissipation, diffusion, noise, tension, gradient, force. We will take a look at next time. And velocity, you saw we just used the swirl parameter here to get this nice swirling pattern within our fluid, which in this case we wanted to look a little bit like smoke. In fact, if we take this down to 5, I'll do another quick play blast. Okay, I've generated another play blast, and as you can see, This one is a lot less swirly than the other one, so a little bit of swirl can go a long way. Of course, the more dense your fluid, the more fluid you have, you have to tweak this by eye until you have enough experience to kind of take a guess the first time out. But I'm going to leave this here, and when we come back we're going to delve into more of these options. We're also going to get something that you might be pleased to show people as opposed to this. This was just a quick look at the emitter and container relationship. I hope you found that interesting, and I will see you in the next part. Hi, welcome back to our second part. Now, in the last part we left off with a simple 2D fluid container, the flat polygon plane, and this smoke effect you see here. Now, I could turn this now into a much better, more realistic smoke effect, but we're going to cover that in greater detail when we go over smoke. We're actually going to do it in 3D instead of 2D. I would like to continue with the 2D container for a moment because it's actually faster for us to simulate, and it's a little easier for me to show you some of the fluid attributes. You can just move your fluid emitters about within the container, of course, so now we'll have more time for the smoke to rise and dissipate, although we have no dissipation on this as such. So what I'd like to do now is show you something that was new for Maya 2011. If I select our fluid, and at the moment if we look here under our density, we just have that set to dynamic grid, velocity and everything else off. And if we let's just bring our emitter back, and let's just plonk it up here, anywhere will do, get it approximately centered. So if we take a look under the emitter properties, you will see that we have here our density method set to add, everything else to no emission. Our density per second is at 1. Now, what new for Maya 2011 was something called a density emission map, which has a variety of uses, but right now I'm going to use this for somewhat of a special effect, and I'm going to demonstrate how to do the effect, and we're going to go through some more settings with the 2D fluid container, which also apply to the 3D fluid container, and hopefully by example you'll get a bit better of an understanding of what's going on before we delve into 3D fluid containers. So I will just load in an emission map now, which will just be a simple black and white image. So just go to the checkbox here, select File, give it an image, and I have this one prepared. As you can see, it's the SimplyMaya logo. You can use whatever black and white image you want, or any grayscale image. Where it's black, it's not going to emit any density. Where it's white, it's going to emit full density and varying shades of grey in between. So if this was white going to grey along here, obviously the nearer to black the less it emits, the nearer to white the more it emits. But for this particular instance, we're just going to use this simple black and white image. So now I have that loaded onto my plane here. I'm just going to scale my plane, so I'll make it yay big. And now what will happen, in fact, I'm just going to go into the plane itself's render stats. I'm going to get rid of its primary visibility so we won't see it on the render, and I'm going to press Ctrl H to hide the plane because I don't want it appearing in my viewport here. So now if I push play, you'll see that the SimplyMaya logo starts to come in, and when it hits a certain density it will start to behave like smoke. And this is a little slower, of course, because we're now having to do more calculations. But as you can see, I now have my logo coming in and turning into smoke. However, what I'd like to do with this is simulate an ink drop. In this case, we can turn the SimplyMaya logo as if it was made of ink in a glass of water, and I want that ink to dissipate within the water. So we can think of the boundaries of our fluid container as the edges of the glass, and this is our ink drop that's going to run. Now at the moment it looks like smoke because this is by default how density within Maya works. So what we're going to do is we're going to set this back I'm going to hit play here. Now I want my fluid to initially start like this. So what I need to do is select my fluid emitter, and I'm just going to set this to be its initial state. Like we talked about last time, you have to constantly rewind and resimulate. I do not want to simulate these first 14 frames every time, because I don't want the effect of the logo fading in within this particular container. It's not an effect I'm looking for. So to combat that, I'm going to tell Maya that this should be where the fluid starts from. So this is quite simple to do. I just need to set its initial state, which I'll do now. Right, so I'll just go up to Fluid Effects, and under Fluid Effects I want Set Initial State. Just go to its Options box and make sure the initial state for everything is selected. Now actually I'm not using temperature, fuel, color, texture coordinates at the moment, but I'll just go with the standard anyway and hit Apply. Oh, I have to of course select the fluid. So apply, there we go, and you'll see this here, set initial state, 111, true for everything. And now when I rewind, I'll be on frame 1, but it will start from here. So now if I play, you'll see that it just goes straight towards being smoke and doesn't have to fade in first. And you can use that set initial state for a variety of different reasons. Most of all, to get the fluid where you want it at the start of the animation, you'll set the initial state, and then when you rewind, that will be your first frame. What I want to do with this right now is I want this to dissolve, and it's not going to dissolve upwards in water, because I want it to look like it's kind of been dropped in the water and then ink runs off it and the whole thing just dissipates in the water. And at the moment that's just not happening. So we still have swirl set. So if we go to content details, and we just reset our swirl back to 0, and this should all be default 0.5 buoyancy 1. Okay, so if we play now, you'll see it just goes straight up with no real swirl pattern. Okay, but the thing is as well, this is just going to keep emitting from the surface of this emitter. So if we let this play, this is never going to dissipate, because the emitter itself, which now using one of these emission maps is emitting in the shape of SimplyMaya's logo, is just going to keep, as you can see, it's adding density voxels all the time. It's adding density all the time. So, this is never going to look like it's an ink kind of effect that's dissolving in water. So the way we're going to get around this is on frame 1, we're going to select the fluid emitter itself, and it has a density voxels per second rate of 1. So I'm just going to set the key for that. I'm just going to go to frame 10 and set this to 0 and set key. But because we set our initial state, most of all of the density per second, the density we already have in the scene from the initial state. So when I play this now, you'll see it dissolve up after frame 10. It's no longer adding any density. So it just disappears and the fluid starts to swirl around. But it still looks like smoke. It doesn't actually look like ink would look when it dissolves into a glass. So as it's floating upwards, and I want ink to be heavier than water, I want it to go downwards. And a very simple way of doing this is going to dynamic simulation in your container, which would be up here, and changing the gravity from 9.8 to minus 9.8. And now when we play, we will get kind of fluid running into water, but again it doesn't really look like ink, it still looks like smoke. So now we'll go to a tab we haven't really used before. First thing I want to do before we go and look at the color of this and the incandescence ramp and the shading of it is I just want to change the dissipation to say 0.5. And what this will do is this will dissipate the fluid. You'll see exactly what I mean in a moment. Now our fluid starts to dissipate out, and by say frame 200 it will be gone, which is the effect I'm looking for with this. I want this to look like it's just melted away into a much larger body of water in this case. So I'm going to leave that dissipation at 0.5 for now. I do want a little bit of swirl, so I'll put that to 2. And now we go down to shading, and this will bring up all the shading options for this particular fluid. Now at the moment our incandescence ramp is set to temperature and our opacity is set to density. If I set our incandescence ramp to density, what you'll see here is, as this plays through, actually I also need to set the color to black so you can see this incandescence. Okay. So basically what's happening here, you can see this is this kind of dirty brown color. The denser this fluid gets, the higher towards the right hand side of the scale it will be. So if this was extremely dense fluid, it would be bright yellow. If it was, you know, extremely undense fluid, for want of a better word, it would be black. So if I just Alt B this, so we get the background in black, so we can see this a little better. When I play this now, you'll see what's happening as fluid is building density. It starts to go a little bit lighter. Now, not quite to yellow because we don't have enough density, but if I go and turn the input bias here to say 0.4, you'll see we now get more of this spectrum. So as I play now, you'll see this go more towards yellow, and then as it dissipates out, it dissipates towards black. Okay, so if we wanted this to go completely towards yellow, we'd need to go to the density, and we'll turn the density scale from 0.5 to 1, and that again has pushed it further towards this end of the spectrum. You can now go to 2, and that gets quite close to this end of the spectrum. So now as more voxels are released over that first 10 frames, as more density is released over those first 10 frames, you'll see it takes longer to dissipate, and also gives you a broader range along the color here. Now I can give you a more, and you'll see we now have more yellow because as we move this further back, there's more yellow at this end of the scale, so we can start out there. This is very useful for creating fire. So white hot, and then yellow, and then red hot, and then going towards more orange, dissolving into smoke. The opacity ramp we can play with here. If I get this to a good frame, I can show you what this does. Okay, this will control the opacity of the fluid. So if I just click here, you'll see I can get more yellow, less yellow, make it more transparent, less transparent. This will go into in a lot greater detail when it comes to creating actual fire. For this particular part, we don't actually need it. Just know that this corresponds to this. It's just which parts of it you want to make opaque. So I'll just grab this. Actually, I'll just leave this on its default straight path. So now at the moment you can see that by playing with a few settings, we've got the full range of our opacity ramp, our incandescence ramp, which is set to density. We've turned our selected color to black. This is so we can see all this. If we select this to white, for instance, it will just be white. So you can think of black in this case to see-through towards the incandescence gradient as opposed to just one pure color. The transparency, of course, will control how transparent your fluid is. White is completely transparent. Black is completely untransparent. Depending on the effect you're going for this particular one, I think I'll just leave it around here. And what we have now is something that looks like it dissolves. Now I'll do a render of this because this play view is not perfect. But what I will do is, I've never quite seen this particular color of ink, which is sort of the effect I was going for. So I'm going to use a light blue ink. Actually, it's not that light blue. Let's go sort of here. and then this would go towards the darker blue, so sort of up here will do, and then of course I'm going to put this back in the middle and hit play. And what I'll do is I'll create a play blast of this just so you can get a better look at it. I'll be back in a second. Okay, my play blast is done. I'll just rewind that and play it for you. And as you can see, we start off with the SimplyMaya logo that dissolves downwards into our container. We just play that again, and there we go. And then finally it dissipates to black and seems to fade into the background. Now the problem we have here is it dissipates too fast, or should I say it loses its color too quickly. By halfway through we were at completely black. So what I'd like to do is fix that. There's a few ways to do it. We can either use the opacity ramp, or we can simply move this down here and press play again. Excuse me, press play again. So now you see it starts out a lot lighter blue and stays a lot lighter all the way through its journey. And there we have it. I mean, you can do some pretty funky effects with this. If we wanted to go a little bit off the wall, if you put a green in here, you'll see it's kind of greenish blue because we don't actually get up to enough density to go to this blue. And as this dissolves, it'll go to green and then towards blue and then finally to black. Now you can completely control the shading of your object with the color, the incandescence and the opacity. I just wanted to go over these briefly. When we create actual 3D smoke and fire, the settings we make in here will be a lot more complicated than this. They'll also need to, let me just put that back to 0, sorry. They'll also be need to tweak. I mean, for here, for fire, I'd use maybe 12 or 13 different shades to get a nice looking fire, and I'd play a lot with our opacity ramp here. As you can see, just putting the input bias of this to 0.4 has made this on 138 a lot lighter. So if we play this now, you'll see we've gone some blue in the middle here from the top of our incandescent scale, and then you can see the darker blue come in, around, and then finally the fade out, which now takes a lot longer with the input bias being higher. So I'll take a quick play blast of that, and you can see that these values are all interrelated, but also small changes in these values can make a large difference in your fluid simulation. So let me just take a play blast of this. Okay, my play blast finished, so I'll just play it for you guys. You can see here that we have all of the colors we set here in our incandescence ramp. When the fluid is finally dissipated enough, it will become completely black. Before this, when it's at full saturation, if you like, it will be this light blue, which if I play this for a moment, I'll just have to skip a few frames, you can kind of see this is more towards the greenish blue, this color here, but you can see some patches of this blue. That would be where the fluid's denser than the surrounding fluid, and as it goes green and then blue, you'll see it will go blue, this dark blue around the edges as it starts to dissipate, and then it will turn to black. If we just cancel the play blast, and I'll just need to resimulate this for a second. I'll take a render of it so you can see what it looks like in the render view. So if I stop it there and take a render, there you can see we have our fluid, and what I'll actually do is, under the transparency, under shading, if you wanted to make this look sort of ghost-like, if you were going for a special effect, sort of a title sequence dissolve, you put the glow here to say 1, and we'll do another render. And now you've got this ghostly glow. I'll actually do a render of this sequence out for you guys when we finish this part, which we almost have. But just so you can get the feeling that Maya fluids are not only useful for smoke and fire. There's a lot of things you can do, from sort of plasma-like effects to space nebula to star fields, in the next lesson, after I've rendered this out, we'll take a look at how fluids interact with fields and also how fluids interact with nparticles. And hopefully over the course of these 3 or 4 beginning lessons, you'll have a kind of feel for the fluid shape tab, which is very daunting when you first look at it, because there is a lot of options. But hopefully by just tweaking a few, so the shading we've looked at with our incandescence and opacity, we've looked at the fact that you need to use selected color to black, so our incandescence ramp shows up. We've looked at the transparency, the glow. Well, again, we've just played with density so far. We haven't even added fuel and heat yet. So what I'm going to do now is I'm going to tweak this a little bit. I'll save the scene file so you have it, and I'm going to do a render of it, and I'll be back when I've done that. And you can see you can get some fairly nice effects with Maya fluids fairly quickly, and you can just let your imagination run away with you. You can actually tweak these values to your heart's content. The worst thing that's going to happen is you're going to have to start again or hit undo. And before I just leave you and tweak this so we can get an animation out of it, I just want to say that with glow, a lot of you probably already know this, but as I'm about to animate this glow, if you didn't know, if you go up to Window, Rendering Editors, and then you go to your Hypershade, in the standard glow node in Maya, and this is my fluid material, but in your standard glow nodes you have auto exposure. Now this will attempt to stop the glow being overexposed. If I untick this and then re-render, you'll see huge glow. Now the problem with auto exposure, it's very nice on a still shot, but if you have it ticked for an animation, what will happen is because it corrects every frame, you'll get a strange flicker in your glow a lot of the time, and it's not what you want. So I'm just going to go down to glow attributes and turn the glow intensity down to 0.2 and the threshold here to 0.1, and then re-render, and it's still a bit glowy. So in order to fix this, I'll just go to my fluid, and then under the shading I'll turn the glow intensity down to say 0.5 and hit render again. It's not quite there. 0.7, still not quite there. 0.8. Okay, there we go. Now I'm getting some glow. 0.9 even, I think we could push it to. That's probably a bit too much. 0.85. But as you can see, you'll need to play around with this to get the sort of glow that you're looking for, if you are looking for glow. And make sure you turn that auto exposure off if you're thinking about rendering this out as a sequence. Okay, now I am just going to tweak this. I'm just going to play a little bit with the incandescence ramp and the opacity ramp. I will save you the scene file so you can see what I've done, and then I'll do a render, and we can take a look at our first effect, rendered effect with Maya fluids. When we come back, we're going to stay with 2D containers, and we're going to take a look at external forces on fluids, things like wind and other Maya fields, gravity, whatnot. So I will be back with the animation, and then I will see you in the next part for a look at how external forces can affect fluids within Maya. Okay, I rendered out just a few frames in an animation so you can see the difference between the play blast and what it would look like when it was rendered. Now here's the effect that we got. That was one, and then we should have another one coming up. Here's another one. So as you can see, just by playing with a few settings here, you can get some fairly creative results really quickly with Maya fluids. We started out trying to dissolve ink into a glass, and I mean, you should now be able to do that. This is just with some glow and to demonstrate the principles of the incandescence ramp and the opacity ramp, and some of the different colors and things you can get within Maya fluids, the different rate of dissipation and whatnot. So hopefully all this is going to work as a base understanding for you guys, so when we actually go into creating the real smoke and fire, and we get a little bit more technical and we add more detail and we get something that looks more realistic, you'll have, you know, some understanding of what we are trying to achieve and how we're trying to achieve it. Because one of the things that puts people off with Maya fluids is the fact that you get this, and then you have different emitters. You have density, velocity, temperature, fuel, that can all be emitted from the same emitter. It can get confusing really quickly, and when you look at this drop down here, I mean, it just goes on and on and on, and it's one of those things when if you're new to Maya dynamics especially, you can start to flick through these and get completely lost. So hopefully just taking you through some shading basics, how to make these different color patterns with the incandescence, how to use the opacity ramp, the input bias, just with a simple density, reversing the gravity to get the fluid to fall downwards. It will start to show you that this is actually a process that can be quite fun to tweak. It's not as scary as you think it is when you first see it. So we're going to come back and we're going to, as I said before, delve into some Maya field effects, things like air and whatnot. So I hope to see you in the next part. I hope this has been useful. If you've had any problems with any of this, or you need some clarification, please don't hesitate to ask on our forums over at SimplyMaya, and I will see you in the next part. Thanks for watching. Hi, welcome back to the third part in our fluid tutorial series. In this part we're going to take a look at how we can use some external forces to affect our fluid. So rather than just using the fluid container itself or the fluid emitter to affect what happens to the fluid, we're going to use external Maya fields to affect the fluid. So the first thing I want to do is make sure I'm on the Dynamics tab and go and create a 2D container. I will just reset this to its default settings. Okay, there we go. Apply and close, and as you've seen before, we now have a 2D fluid container. We will get on to 3D fluid containers in the next lesson. I'm just simply using a 2D container for this, as I'm not moving the camera, I'm not interacting with any other 3D objects, so I really can get away with a 2D field, and it is a lot faster. So what I'd like to do to start with is just add an object we can use as a surface emitter. So I'll just add a polygon plane here, and again, like we did last time, just rotate it 90 in X. And what I need to do, of course, is connect it to the container. So I'm going to shift select the container and the plane object, so they're both selected. Then I'm going to go up to Fluid Effects, add Edit Contents, and Emit from Object. I want its options box. Now, if we reset this, you'll see that it's emitting density, heat, and fuel. I'm just going to go and use density at this time. I'm going to have it as a surface emitter, and that should be fine. So apply and close. You can see down here I've connected the dynamic emitter. And if we hit play now, you'll see, if I press 6 for shaded view, pretty much we're just emitting some density from a plane, same as we did in the first lesson. Now, so you can see that's exactly what happened in the first lesson. I'm going to scale up my plane, and what I want here to show you how the external force is going to interact with this plane is to just not have this smoke move or this density move. So again, I'm going to use a emission map. So I'll just make sure I have my fluid selected here, attribute editor. I want to go down to, sorry, not my fluid emitter. I'm going to go down to its density emission map. I'm going to use a file, and again I'm just going to use my SimplyMaya logo file, simple black and white image. I'm going to select the emitter itself, the polygon plane, and hit Ctrl H to hide it. So now I can see that I have my SimplyMaya logo forming. Select the fluid container. I'm going to up the resolution to 200 because I'm using a 2D container. I can get away with this without it taking too long. So now when I hit play, I have a much higher resolution. Okay, now what I want to do is, if I leave this to play, it will of course do what it did last time, which is just send this rather smoky looking fluid up in the air. And I would like this to be fairly static, because I want to show you how the Maya fields are affecting it as opposed to how the container is affecting it. So to achieve this, I'm just going to select the fluid container. I am going to turn the buoyancy off, and when we play now we will get something that stays a little more static. What I'd also like to do is make this the initial state of the fluid. So fields effects, same as we did last time, set initial state. So now when I rewind, this is how our fluid starts. And as I'm happy with this shape, and really if I play now, fluid will be continuously emitted into this container. If we see, we just give this a few frames to run. And as you can see, this is getting denser and denser and denser. And that's not what I want. I'm continuously emitting fluid. And see, as I rewind, you'll see it go a lot lighter. This is enough fluid for me, so I'm going to go to the emitter itself. And as we have an initial state with density already in there, I'm going to set this to 0. So now when I play, you'll see it's much faster and absolutely nothing here changes, which is exactly what we're looking for. So if I go up to the fluid itself and density scale, I'll set to 2. You see now we have a denser fluid in the scene, but still when we press play nothing will happen because we have no buoyancy, no dissipation, no noise. We have nothing to affect this. So now what we need to do is connect some external force to this container, say an air field, which we'll use to generate wind in this case. Now there's two ways you can connect one of these. You can go up to fields and drop in an air field. If I just move that out of the way, you'll be able to see it. If I press play now, nothing will happen. This is because it's not connected to our container. So if we select our air field and then shift select our container, you can see here in the outliner both are selected, and we go up to fields, affect selected objects, you'll now see that it has an effect on the fluid within the container. Now if we take a look at the attributes of this itself, you can see that if we change this from Y to X, it will actually be blown across the container, the fluid that is. Now you'll notice that you don't have to put this within the container itself. It's enough that it's connected to the container. And remember, the fluid can't leave the confines of the container. So this is a very simple way that you can now create layered effects. You can use the container to, let's say, create the swirl within the smoke, same as we did before. We'll set the swirl to 10 and we'll replay this. Okay, that's actually not enough swirl for us. If we set the buoyancy now to 1 and the swirl to 25, we can now start to layer these effects together, and I have smoke that goes up and is blown to the right by this field here. I also have the swirling smoke pattern. And so this is just one of the ways in which we can build up layers within these effects to create many different types of movement within the fluid rather than solely relying on the fluid container itself. If I set the swirl back to 0 and the buoyancy back to 0, I'll delete the airfield. I'll show you a few more fields just so you can get an idea of the sort of things you could actually do. Excuse me. So if I go to fields now, I'll put a vortex in. I'll just make sure that it's reset to its default settings and create the vortex. I'm going to leave this in the center, and when I hit play, you'll see again that nothing has happened. So we could now shift select this and go up to fields and affect selected objects, and this would work. Unfortunately, with our vortex, the magnitude of it is not high enough, so we'll set it to say 100. We'll try again, and now you can see our vortex affect our fluid. Okay, the other way to do this, if we just delete this vortex field, the other way to do it, rather than adding your field and then selecting your container and then adding it to affect selected objects, you can simply select your container, and then if I drop my field in, change the magnitude back to 100, it will be automatically connected to the container I had selected when I added the field. So this is a bit of a time saver. You can do it either way. You can also take a look under the relationship editors, the dynamic relationships, to see what's actually connected to which field. So if I just unclick this, this is no longer connected. If I click it here, it will be connected. So if you have complicated dynamic fluid simulations, maybe with a few fields connected, a few external forces connected, you can then use this relationship editor to get a better overview of what is and what is not connected. So another thing I'd like to show you is if we just get rid of this vortex field now, because I think you get the basic idea of using some of these fields to affect the simulation that you're doing. We can also keyframe and animate these fields. So if I wanted to do something like a cannonball passing through this particular simulation we have here, which at the moment doesn't do anything, I can use, let's try volume axis. So it's options box. I'll just name this ball and reset its settings first, sorry. Make it a sphere. Okay, away from center, I'm going to set at 10, and I'm just going to hit apply. Okay, so now you can see we have this ball here. I think I might resize that a little bit. So, and just move it up. And what I want to do is I want to animate this passing through the smoke and knocking the smoke out the way. So we'll put this here, and we'll just keyframe that. So if we go to the channel box, and we'll just keyframe its translate Z. So key selected, and then I'll go to say frame 70. I'll just move this to here, and again key selected, and now it'll move through. So if we take a look at what that's done, the magnitude probably won't be set high enough, but we'll have a look. Nope, the magnitude is definitely not set high enough, so I'll make sure I select my field here, and magnitude I will make 25, and we'll see what this does. Nothing. So at the moment I obviously have a problem, and the best way to see what's happening here is go to our dynamic relationship editor. So again, dynamic relationships, select the fluid, and I can clearly see here that my ball was not connected. Now if you look at it in this view as well, you can already tell if something is connected as well, because at this point it's sort of a light reddish browny color. As soon as it's connected, it will go bright purple. So again, the relationship editor helps you quickly see what mistakes have been made, or what you might have forgotten to connect it, or what's connected that shouldn't be. So I'll just close the dynamic relationship editor, and we'll take another look at this. Hit play. And now you should see that it blasts the fluid out the way as it passes through. And obviously you can then reselect the emitter. Maybe that effect is a bit too pronounced, so we'll select not the emitter, sorry, the field. So we'll select this, and we'll set a magnitude of say 5, which is its default value, and we'll try this again, and you should just see it more gently knocks the fluid out the way. So these effects again can be used in combination with each other. Our fluid at the moment within the container is static to give us a better view of what these fields are doing. But we'll be using fields later on in the tutorial as well to create more realistic smoke and fire. But there you go. I mean, that's the way you can use external forces in Maya in conjunction with a fluid container and a fluid emitter to create more complex effects. Okay, I hope you found that useful. In the next part, we're going to take a look at how we can use nparticles with Maya fluids. I hope you will join us for that. Thank you.